Hello, ladies and gentlemen. Welcome to Math 30-1, Chapter 6, Section 4, Graphing Trig Functions Notes, Part 1. Now, as a review for you guys, for the function y equals x minus 2 divided by x plus 1, I want you to identify the equation of the asymptotes, the domain, the range, and the intercepts of the graph. Now, really, the first thing you should be doing is graphing the darn thing. So while you're drawing the graph, I'm going to do this algebraically, stuff you should know. Asymptotes, that is when your denominator, x plus 1, now, since this doesn't cancel out, we have a vertical asymptote here. Now, next thing is the domain. This is going to be a function of x is all real, except x cannot equal minus 1. Now, the range, here, it's some sort of function that goes like this, I'm assuming. So, y is all real. Now, since I haven't drawn the graph, I have to do some thinking. Now, here, when talking range, we're talking horizontal asymptote. So, as x goes to infinity, y is equal to, now the equation is x minus 2 over x will be, oh, you poopy head, x over x, which is infinity over infinity, which is 1. Which tells me there's probably a horizontal asymptote. Y cannot equal 1. I think. But once again, I'm not drawing the graph. You guys have to do that. Now, the intercepts. X-intercept, y equals 0. 0 equals x minus 2 over x plus 1. Now here, first thing I do is I multiply both sides by x plus 1. So this becomes 0 equals x minus 2, or x equals 2. So I have an x-intercept at 2. Now, for y-intercept, x is 0. This is y is equal to 0 minus 2, or 0 plus 1, which is minus 2 over 1, which is minus 2. So, y-coordinate is minus 2. Now, can I draw a crude graph from this? Yes, I can. Oh, sorry. I have a vertical asymptote at x cannot equal minus 1. I have a horizontal asymptote at y equals 1. And I have two coordinates, two intercepts at x equals 2, which will be over here, and y equals minus 2, which strongly suggests a graph like this. And that means the other half will be something like that. And that should be what you got on your graphing calculator. Okay? Now, the other thing are the special triangles. Yes, I'm going through this quickly, but you should remember it. 45, 45, 90, and 30, 60, 90 triangles, because I need you to be able to come up with the sine and cosine of all these angles. And honestly, this is where I point out the left hand, probably the better one to use. 0, 30, 45, 60, 90. Number of fingers above is cos. Number of fingers below, so square root of 2. So, 0, 30, 45, 60, 90. That's what I need you to be able to do. Okay? I'm not going to do that. You can watch the video again from 6.1. Now, here, I need you to complete these tables. This is the meat of the lesson here. So, sine of 0 is 0. Pi over 6, you've done radians, it's pi over 6 radians. I want you to convert that to degrees. That becomes 30 degrees. Sine of 30 is 1/2. Sine of pi over 4, now pi over 4 is 45 degrees. That's root 2 over 2. Pi over 3, that becomes 60 degrees. It's root 3 over 2. Pi over 2, or 90, is 1. That you should be able to do with your left hand. right off the bat. And then we keep on going. 120 degrees, that's going to be root 3 over 2. 135 degrees will be root 2 over 2. 5 pi over 6. 150 degrees will be 1/2. And pi, or 180 degrees, will be 0. Now, I did that quickly, and I was doing it with my left hand, and you can't see that, which kind of sucks, but remember, this is y over r. So in the first two quadrants, y is positive. So you get all positive sign values. Now, drawing the graph here, 0. Pi is 0. Halfway in between is 1. Now, pi over 6 is here. 1/2. Sorry. I'm going to do this. My apologies. I'm doing this quickly in my head. Pi over 6 is halfway between 0 and pi over 3. So pi over 6 is here. Oh, come on. Here. That's 1/2. Now, pi over 4, or 45 degrees, is root 2 over 2. Now, that is halfway. Pi over 4 is halfway here. Be here. Now, root 2 over 2 is 0.707. Pi over 3 is 0.866. So I'm getting something like that. Now, I did that kind of quickly, but grab your graphing calculator and confirm that for me. 1/2, 0.707, 0.866. So it should look something like that. And we draw a nice smooth line between them. And that's half our sine curve. Okay? Now, here comes the nasty half. 7 pi over 6, that is 210 degrees. 5 pi over 4 is 235. 4 pi over 3 is... Oh, brain fart, I can't do that in my head anymore. So that's 225, 240 degrees. 3 pi over 2 is 270. 300. 315. 330. 360 degrees. Sorry. Now, I've done enough of these that I can do most of that in my head. Obviously, I need some practice. Double check turning my radians into degrees. So pause the recording, double check, make certain I got that right. And then we're going on to the second quadrant. 210 degrees is down here. It should be 30. So the reference angle is 30. So sine of 30 is 1/2. But we're in the third quadrant where y is negative, so this is minus 1/2. Come on, don't do that. People are watching. I do that when people are watching. You want that? It's supposed to be minus 1/2, and the hand is moving around just to confuse me. Now, 225, that's 45 degrees. So that's going to be root 2 over 2. It's going to be negative. 4 pi over 3, the same as 60 degrees. So that's going to be negative. 270 is the same as 90. And you see the pattern forming here. Okay. Now, graphing it is a bit of a pain in the bum. I fully admit that. But 2 pi is 0. Halfway in between will be minus 1. Now, 4 pi over 3, let's do some of these numbers. 4 pi over 3 is minus 0.866, something like that. 5 pi over 3. Now, 11 pi over 6 and 7 pi over 6. Now, if we count 1, 2, 3, 4, 5, 6, all right. 2 of these lines is 1/6, so this is 7 pi over 6. That'll be 1/2. And this will be 11 pi over 6. So that'll be 1/2. Halfway between 30 and 60 is 45. 45 is minus root 2 over 2, or about 0.707, just a little bit below. Here. And there we go. That is the sine curve. All right? Now, I got those points. I was able to graph it. Now let's finish this page before we go take a break. Don't be there. Don't be there. Come on. Domain. Now, here, we started at 0, and we went to 2 pi. And notice I'm using square brackets because that's what I told you. Zero to 2 pi. The greater than or equal to means I include the 0 and the 2 pi. So it's square brackets. Now, I could write it like 0 is less than or equal to x, which is less than or equal to 2 pi. Now the range, minus 1 to 1. Notice the maximum value is 1, the minimum is minus 1. Or minus 1 is less than y. Now, so the intercepts of the graph. So what is across the axes? 3 points. Okay. So that is 0, 0, pi, 0, and 2 pi, 0. Right? Now, what happened? Sorry, I'm going to stop there for a sec because I want one more important thing before I pause the video. For this graph, those are the intercepts, and that's the domain and range. Now, what if I said all real? What if instead I said draw a graph, and I wasn't specific about the domain? Well then, I want you to realize this graph keeps on going. So, if it kept on going, I would have to say the domain, x is all real. The range doesn't change. Okay, now, one thing here, I would have to come up with a general equation for the general solution for the intercepts, or equation. Now notice what's happening here. It starts at 0 and goes pi, 2 pi. So it repeats every n pi. Now, where does it start? Traditionally, we would say it's 0, but the trouble is 0 plus n pi looks kind of funny. So we go to the first point after, which in this case is pi. N is an integer. All right? Remember, that's how we write integer. Now, that's it for the first couple of pages. If you've got this, great. If not, watch the video again. Look at I'm plotting the points, turning radians to degrees, and finding those coordinates. Yes, it's a pain in the bum. Yes, I did it kind of fast. But you also remember 6.3, I gave you the handout. Where is that? The unit circle. So you can copy off of this, but you better know what the numbers are. All right? Now that's enough for the moment. I'm going to pause here. You guys watch the video again if you're having troubles. Otherwise, on to the next video, please.